Hey guys, welcome to Docker Simplified, an installation session by Scalar. So in this particular session, we'll be understanding the very basics of Docker, and also we'll be looking into how to install Docker in a Linux environment so that you could start with Docker. Okay, we'll also see more concepts later, but for now we'll be looking into the very basic concepts. So we'll be covering what is Docker, why Docker, the difference between a Docker and a virtual machine, and the basic concepts, and then we'll move on to the Docker installation part. Okay, so that would be the last part of this particular session. Also, before we move on with the session, please subscribe to our channel so that you don't miss our upcoming videos, and also leave a like. And if you think it's informative, please share it. And also, if you have any queries, leave a comment down in the section. We would be addressing all of your queries. So now, without any delays, let's start with the session. So guys, before understanding Docker, let's first understand what is a container. So basically Docker is a tool which provides the containerization service, but before understanding what's a container, there is no purpose of learning what is Docker. So containers are made possible by process isolation and virtualization capabilities built into the Linux kernel. So basically what a container is, it is a container within a Linux operating system, or any, like, it could be any other operating system as well. So inside that operating system, you could create a particular process as an isolated process. So that process is completely within that particular isolated environment. It does not affect any other processes. So there could be multiple containers within a same server. So all those containers will be isolated from each other. It would be like they are basically individual virtual machines or individual computers, but a tinier computer within another computer. So it might sound confusing, but it's pretty simple. So let's say if you should know about a virtual machine before understanding about containerization. So a virtual machine is a complete server which you can launch, but a container is again a virtualization tool or a virtualization service which you do within the other virtual machine or in another Linux environment. So that basically is containers. A container technology offers all the functionalities and benefits of virtual machines, including application isolation, cost-effective case scalability, and disposability. And also there are other advantages. So first, let me just tell you the first three things. Application isolation is basically that you can run, let's say in a normal virtual machine, you can only have one version of Python running. Okay, when you're using containers, so you could have multiple versions of Python running in one single virtual machine. If it's a normal virtual machine, you can have only one version of Python running at one single point of time. Most applications work that way because you can only have one version of that application running in your system. But let's say you have an application which requires 2-3 versions of Python. So you can have 3 different containers which are running 3 different processes within them using 3 different versions of Python, because you could install a different version of Python in each of those containers because they're isolated completely. Okay, so that's what you can achieve with a container. And also the other things are lightweight. So lightweight in the sense you don't have to create a complete operating system, and it doesn't have to run all the operating system processes because it's a smaller virtual machine within another virtual machine. So unlike virtual machines, containers don't carry the payload of an entire operating system instance and the hypervisor. They include only the operating system processes and the dependencies necessary to execute the code. So normally when you create a virtual machine, it's a complete system. So it's a complete server. So in that, the virtual machine will have to handle the operating system processes. If there is another application running, it will have to look into those processes. So basically whatever is running, whatever processes are running in that entire virtual machine would be handled. And also if there is an application is running on top of that, that also has to be monitored by the virtual machine itself. But if it's a container, in that case, you only have the application running within it. So it doesn't have to monitor a lot of things. It will only have to monitor the operating system processes which are related to it. Okay, and also the dependencies which are available to execute this particular code, which is inside the container. Okay, so now greater resource efficiency. With containers, you can run several times as many copies of an application on the same hardware as you can use virtual machines. This can reduce your cloud spending. So one more thing is that, let's say you can, instead of having multiple virtual machines for the same application, you could have one, let's say a high spec virtual machine, and inside that virtual machine you can have multiple containers running. So this will reduce your need to create an auto scaling group and increase the number of servers or decrease the number of servers whenever traffic goes high or down, because right now you just have one server. Within that you have multiple containers to handle everything. So this will obviously reduce your cloud spending, because you don't have multiple servers, you just have one or two servers. Inside that you're running containers. And finally, improved developer productivity. So if it's a virtual machine, then you will have to install, so configure whenever there's a problem, you'll have to handle it, you'll have to restart it whenever you provision something. But if it's a container, then you can just rerun the container, you can rebuild the container if there is a minor change, and it won't take as much as time as to reboot a complete server, right? So because of this, it makes containers ideal for a CI/CD pipeline. So CI/CD pipelines are basically to make sure that there's a release cycle every now and then, so that the application gets a lot of updates. So you can learn more about CI/CDs, and you can learn more about DevOps and Agile. You can just check out Scalar channel, or you can just type in Google and learn about that if you do not know what it is. Yeah, so that's basically it. And so improve developer productivity. One more thing is that it's much faster for a container to start, and a developer can just use a existing container, pull it, and then just make minor modifications. They don't have to basically launch a complete server and configure everything inside of it. So this is a container. Basically, it's a isolated environment within a server. So now let's see what is a Docker. So Docker is an open source containerization platform. So basically, Docker is a tool which makes sure that you can create containers. So containerization is the process. Docker is the tool which enables that process. So it enables developers to package applications into containers, standardized executable components, combining application source code. So the explanation is for containers. So containers are basically standardized executable components, combining application source code with the operating system libraries and dependencies required to run that code in any environment. So any environment, in the sense, you can run the container in any environment you want. That is any operating system you want, or any type of Linux distribution you want. That's basically one big advantage of containers. You can create a container in any distribution you want, and you can just upload it, and you can pull it from any other distribution, Linux distribution, and then you can still use it there because it will still work. The application code, the libraries, the dependencies are all packaged into a smaller executable component. That is basically a container. And Docker is essentially a toolkit that enables developers to build, deploy, run, update, and stop containers. So you can use simple commands to do this. So while we are trying to install Docker, right, we would understand the basic commands, because I would also show you how we can pull, let's say, pull an image, and also how to start working with it. Okay, so that's what we're going to do. And yeah, it's a basically a toolkit for everything you need to do with containers, and it saves time. And also it has very, very simple commands which you can use to execute whatever you want. You can create an image, build the image, push the image into the registry, pull the image whenever you need. You can make changes to the same image, and then you can basically save it, and then you can again. So basically you can reuse it again and again, right? Okay, so now that's what we're going to see. So Docker is a tool for containerization, but why exactly you should choose Docker? There are other tools as well. Okay, first of all, Docker is the most popular containerization tool. Why? Because it has all of these benefits, and it has all of these things which makes it much easier to work with Docker than any other containerization tool. And also it is open source. Okay, so Docker enhanced the native Linux containerization capabilities with certain technologies it brought in. So containerization was already a popular concept, but Docker brought in more features which made it even simpler. So first of all, improved and seamless portability. So Docker containers run without any modifications across any desktop, data center, and cloud environment. You create the container. It could run in your personal computer. It could run in a data center. It could run in AWS or Azure or any cloud environment you want. Second, even lighter weight and more granular updates. So already it is a small packaged isolated environment. Container is a packaged isolated environment. But Docker makes it even lighter weight by introducing these things. That is, with Docker, only one process can run in each container. There cannot be multiple processes running. If there is only one process running, that makes sure that all the memory, all the capacity allocated to it, all the resources allocated to is fully utilized. And this makes it possible to build an application that can continue running while one of its parts is taken down. So one more thing is that, let's say an application has 10 different micro parts. It has 10 different features, and all of those features are individual containers. So let's say all the containers are running together. So now let's say the developers are making a particular change in one of those features or two of those features. So you can basically just make changes to those two containers, and that would not affect the application at all, because all the other features, all the other 8 features would be working, and the customers will still be able to view and do whatever operations they are about to do with it, right? Only those two particular containers, two particular features would be down, or for updation or for repair, whatever it is. And then once it is done, they can again build and again run the container within it. So that's basically granular updates. And then container versioning. So Docker, whenever you create a container and let's say you update it, it will create another version of the container. It will not overwrite, it will create another version. So it keeps going on. So there will be multiple versions of the same container. So let's say the newer container, there is some bug or issue with it and you don't want to continue with it and you want to make some changes. So you can roll back to your previous version of the container which is working, so that your clients, your end users are using the older version, and then you can make those edits and changes and clear the bugs in your latest version, and then again update it. Okay, again push it. So this is what container versioning will help you with. And container reuse. So existing containers can be used as base images. So this basically means there are containers already available in the Docker registry. You can use the same base images. You can just pull them down and make certain changes to it. So there are already basic templates available. So that's what I'm going to pull from today. I'll be pulling from a base image which is already available, which we can start working with immediately without having to do anything. So that's basically the magic of Docker. And shared container libraries. Developers can access an open source registry containing thousands of user contributed containers. So there are already the container libraries are basically like let's say like it's like GitHub but for containers. So you have all these free repositories, free to fork repositories, where you can just fork it and you can use it for your own purposes by making certain changes accordingly. Yeah, so that's basically shared container libraries, and there are already a lot of containers available. You can just pull and use them according to your need. So this is one thing which is asked every single time, that is, what is the difference between a virtual machine and Docker or containers? So how exactly, so you're explaining all this, so it's an isolated environment, there are multiple containers within one virtual machine, but how exactly it is shown or how exactly it works physically? So what is the physical architecture? So this is the architecture of containers using let's say Docker. Okay, so this is basically virtual machines. So let's say you have multiple applications. So app A, app B, app C, there are like 6 applications which are running within one virtual machine. You can see that, right? It is one host operating system, and the host operating system is running Docker. Within Docker, there are multiple containerized applications which are isolated from each other. So app A cannot communicate with app B within the environment. Same thing goes to any other application because they're completely isolated environments. So this is one single virtual machine. So again, that is cost effective, and so that is easily so you can easily maintain it because they are all within one virtual machine, right? And Docker is already available. You can just maintain it using Docker commands. Now coming to virtual machines, so infrastructure is basically your, let's say you're using AWS, so it's their own infrastructure. They would have an hypervisor available. So that particular hypervisor, using that hypervisor, you can create virtual machines. So in this case, there are 3 virtual machines, and each virtual machine can have only one application running at one time if they are not using Docker. So now you have to pay for 3 different virtual machines and whatever software is running within it. And according to that, you'll also have to create the virtual machines. So you'll have to select the instance type, or you'll have to configure the memory and capacity accordingly. But in containerized applications, you don't have to do that. Here, the virtual machines are isolated from each other, but they are completely separate servers. And so you can see that, right? In every single virtual machine, there is an operating system running. Okay, because they are individual. So this particular application is isolated from this application, but again they are in different servers. But even though they are in the same server, they are still isolated from each other, which is a much better approach than taking up virtual machines. So that's why if every single company you see, every single popular major company are shifting to containerization if they have already not done it. Okay, so yeah, so this is basically the architectural view of Docker versus virtual machines. So now before moving on with the installation, let's look into the basics of Docker. So there are more concepts to it, but I just wanted to introduce the three major components which you'll have to understand. So the first component and the most important component is a Docker file. So every Docker container starts with a simple text file containing certain instructions for how to build the Docker container image. So Docker file automates the process of Docker image creation. It's essentially a list of command line interface instructions that Docker engine will run in order to assemble the image. So it's pretty simple. It's a file with all the commands provided. So when you're trying to create a Docker image, you basically run the Docker file and all of those instructions will get executed by the Docker engine. Okay, so it'll be executed according to the order, and by the order it will assemble the complete image, and the image will be ready for whatever purpose you need it for. Okay, so that's basically it. So to build a Docker container image, you would need a Docker file, which is basically a text file containing multiple commands on what to do. For example, install PHP, then let's say install MySQL, and so once installed, configure that particular MySQL with create this user, and so basically all those commands can be given in one single Docker file. Right? Okay, now coming to the second one, which is Docker images. So Docker images contain executable application source code as well as all the tools, libraries, and dependencies. So Docker file is used to create Docker images. So once the Docker image is created, it basically contains the application source code and also all the tools, libraries, dependencies, everything necessary for that code to run just within the container. It has every single thing for that particular piece of code to run. It doesn't have to contribute to anything else. It just needs all the libraries and dependencies which are required to run that particular piece of code. That's basically a Docker image. So it's possible to build a Docker image from scratch, but it's not necessary because most developers pull an existing container which is already available in common repositories. That's what we told, right? Shared container libraries. Multiple Docker images can be created from a single base image again. So with one single base image, you can go in multiple directions because you can install a different software here, and here you can change the source code to a different source code. So you can have one base image which can be divided into, or which can be created into various different Docker images. Okay, so that's Docker image. And finally, Docker containers are containers that are live running instances of Docker images. So now images are created. So now when you run those images, that's when they become a container. Okay, so Docker containers are live and running instances of Docker images. While Docker images are read-only files, containers are live, ephemeral, and executable content. That basically means containers are live running applications which you can interact with, which you can work with. But an image is already created. It's a packaged element which you cannot change once it's created. You can edit it if you want, but what I mean is once it's created, you cannot interact with it. It's a packaged element which is already there, which is sitting there. When you run it, it becomes a container which could be like you could communicate with it. So users can interact with them, and administrators can change their settings and conditions using the Docker commands which are provided. Okay, so these are basically the very basics of Docker. So now let's go to the Docker installation part, and before moving on with the installation part, let me take you through the commands which we'll be using to install it. Okay, all right. So first of all, I have created this server which is a Linux server. So first thing you'll have to do when you have a Linux server, right? First, always update it. Once you update it, then we can start with the installation part. So as it is a Linux virtual machine, I'm using yum. If it is, let's say, Ubuntu, then it would be apt-get. So you should basically use the appropriate package manager for it. And then this particular command, sudo service docker start and sudo systemctl enable docker. So this will start the Docker command it will start the Docker service, and this will make sure that whenever you start the server, right, the Docker service will automatically start with the server. Once the server is started, the Docker command also will be started when it's booting itself. And then sudo service Docker status, this is to just check the status to understand whether the Docker service is running or not. And then you can create a user. So I'm using AWS. So in AWS, when you create a Linux server, the username is EC2user. So I'm using this username as to basically create a user to the Docker group. If you have a different username, then use that particular username over here. The group name is Docker. You can also change the group name if you want to create another group. And then if it's Ubuntu, the username would be Ubuntu. So accordingly, you will have to provide it. So once the user is created, we can reboot the system, or we can just start pulling it. So we can see if it works. So we are going to pull the Ubuntu server image. Okay, so that's what I'm going to pull. And then I'm going to show you, once I run it, it'll automatically run the container. Then we can, as we are in a Linux system, right? We are in a Linux system. But then once we run the Ubuntu container, we will be inside the Ubuntu environment within the Linux system. So inside that, we could basically type in Ubuntu commands and it would work. So if it doesn't work, that basically means we don't have a proper running container, but that's what I'm going to show you. So that's the magic of containers. When you pull an Ubuntu container within a different Linux distribution and you use Ubuntu commands, it would work because it is an environment within that particular operating system. Okay, so now we've seen the commands. Let's go ahead. Okay, so you can see I've already launched the image. I'm just going to connect to the image. Alright, so we've connected to the image. So let me just, okay, so the first thing you'll have to do, as I told you, is update the system. Okay, so we've updated the system. Next command is to install Docker. So you can provide this -y. So this basically will automatically provide the yes in the command. If it's prompting a yes or no, it will automatically provide the answer as yes. That's why I'm providing -y. So here it would have asked me a yes or no. I've already provided -y, so it automatically assumed that my answer is yes, and it's downloading the necessary information, okay, to install it. Okay, so now Docker is installed. Let's just see if Docker is, yeah, so Docker is not running. I told you, right? So the first thing you have to do is run Docker. So it's asking that it tried to run the Docker command, but it's not able to run it because the Docker daemon isn't running. So, okay, so Docker is not running. So what was the command? It was sudo service docker start. Okay, I'm just going to copy this and paste it here and hit enter. So it basically redirecting us to systemctl. So Docker services started. Next is we have to enable it. Okay, so it is enabled successfully. So now we can see, so sudo service docker status. Okay, so now it shows active. You can see that, right? So this basically means the Docker daemon, now it's running. Before it was not running, but now it's running. So if I do docker ps right now, okay, sudo docker ps. Okay, so now you can see it is working, right? You commonly use sudo when you are trying to use Docker. You cannot directly run the docker command. Yeah, so now it basically shows that it's working. Okay, so next let's create a user. That's it. Just sudo user mod -a-g docker ec2 user. So then it will basically add this particular user. So this user is the you can see this, right? ec2 user. So this user is the main user of this particular server. So I'm adding this user to the Docker group so that they would have access. So now let's again try running docker ps. Okay, so now, okay, so now let's pull some images. All right, so now sudo docker pull ubuntu. Okay, so now it's pulling the Ubuntu image. So the Ubuntu image has been successfully pulled and it's ready to run. So now it's docker run sudo docker run it Ubuntu. So now what do you think will happen? Would we still be in this particular server, or will we be taken to a different server, a Ubuntu server, or a Ubuntu container will run within this server? What do you think will happen? Okay, so now you can see that we are within another root. Okay, so now let's see if this command works. Sudo yum update. It doesn't work. Or let's say yum update. It doesn't work because it's not a Linux system, it's a Ubuntu server. That's why I wanted to use a Ubuntu server to show you the difference between these servers. So if I exit this and if I do a yum update, it will see, so it's working right here because this is a Linux distribution and yum is the package manager. So now let me again run the Docker image. So here let me provide apt get update. Now it's working, right? Because this is the Ubuntu container running within the Linux environment. So you can basically install whatever you want. Let's say apt get install Apache 2. You can install any software you want within the container, and yeah, you can make any changes to the container, even though it's a container which I pulled from the registry, from the common registry. I'm from the Indian region, so I'm providing that. Yeah guys, so basically I showed you how to do that. So now exit. So yeah, so this is basically the Docker installation. It's very simple, nothing complicated in it. So then you can start creating your own Docker images by creating a Docker file and executing the Docker file, which will create a Docker image. Once the Docker image is created, then you can run the container like how I just ran the already created Ubuntu container. So that's it for this particular Docker session, guys. We would do more sessions on Docker. We would get into more in-depth concepts. So for now, that's it. Thank you. So guys, that's it for today's session. If you think it's helpful and informative, leave a like, and also you can share it if you think it would help your friends. And also if you have any queries, leave a comment down below and we will be helping you out. Thank you.